The herd is bewildered. Some have never seen a crocodile before. Even as the full horror unfurls, there is great confusion about just what is going on. And that was just the first attack. Even the adults seem unsure of just how much danger they're in. The calf's desire to quench his thirst overcomes any fear he may have.
I'm Daniel, and this is my family team from Secure Supplies. We have preserved and rebuilt green technologies actively around the world now for over 18 years. The water fueling and gas phase change technologies are changing the way your world's power and gas industries work. Helping you access these technologies is our life mission. Click the subscribe button now to join our technology releases and updates every Monday. And consider buying a ticket to the show by pressing the link in the description. If you would like to see the secrets ahead of time, head over to our Patreon tech training releases every Friday.
Okay, this is an explanation of Stanley Myers and Stephen Myers' sport-powered car. The reason you're giving you an explanation is because you can pretty much see everything on the car in this particular video, and it definitely warrants a thorough explanation of what's going on in this car here, this picture.
further development on the technology, centered around also the development of what we call the laser accelerator control. And this had to be developed in order to translate from a mechanical displacement to an electronic displacement in order to allow the hydrogen computer system to produce the gas on demand based on acceleration control. So what you're really seeing with the water fuel cell as it is today is that we have a full system engineering approach allowing us now to use water as a main fuel source to be able to run a conventional engine and run it on water and do it and equal or supersede the performance of a car running on gasoline and diesel fuel. Many people do not realize that when you run a car or truck on either gasoline or diesel fuel, you're actually running it on hydrogen. And all we're doing is using the hydrogen from water. Under the National Bureau of Standards figures shows that when you use water, the energy release is roughly 2.5 times more powerful than that of gasoline. So water is a very powerful fuel. And all you needed to do was solve the answers of, number one, producing the hydrogen economically, controlling it on demand, able to adjust the burn rate of hydrogen and gas to co-equal the fossil fuels. order to run this engine off of water, we've also had to learn the ability to adjust the burn rate of hydrogen to co-equal the fossil fuels. We did this by simply now pulling off a portion of the exhaust gas that's coming from the engine, as you see through this tube here, that's going through this electronic regulator that's hooked up to the hydrogen computer. And basically what's happening is that as the...
So stick with me here. That little valve he was pointing to is controlling the amount of exhaust gas recycle going in to the burn.
Ambient air is going into the engine and going through the burning process. It produces the non-combustible gases that retards the speed by which the oxygen atom unites to hydrogen and bring on gas ignition. So by simply using the non-combustible gases coming from the exhaust of the engine, we now modulate and control the speed by which that oxygen unites with the hydrogen, and therefore we are adjusting the burn rate of hydrogen to co-equal that of gasoline or fossil fuels or even diesel fuel, and that gave us the number one.
So the hydrogen and oxygen basically burns at 2.5 times the explosive energy of, for instance, petrol, and so it burns at a much faster rate as well. So per cycle you would need, just to keep the engine running, 2.5 times less fuel, which is the hydrogen and oxygen, which means that you're mixing considerable amount of exhaust gas recycle into the hydrogen and oxygen to bring it down to the same burn rate as petrol or butane or diesel.
One, retrofit capabilities are retrofitting the water fuel cell technology to an existing engine, and we do this electronically. And the third one was to be able to transport it without spark ignition. And we've solved all of these problems on the design engineering. The unit you see right here, this is referred to as a resonant cavity. Water is now fed into the resonant cavity through this water tank, and as such, we now expose the water to a very high intense pulse voltage field and restrict the amps, and therefore the electrical polarization process now allows us to release the hydrogen economically from water. And by attenuating the voltage field, the amplitude of the voltage field, we now can control the rate of the production of the hydrogen gas on demand. So this is what's referred to as a constant demand generator.
So this generator is controlled, like I said, from the GMS system. It's got a pressure regulator on it, which tells the GMS system that it's full and stops. This is the cards that are used for, they're called the voltage intensifier circuits. Now they, basically there's one for each cell, and they are efficiently producing hydrogen and oxygen from this unit, and it's centrally controlled from the ECU, which is actually a GMS unit.
We also now extend or allow the voltage amplitude to increase even to a higher level, and allow the water atoms to go into an ionization state, which gives us the ability even to produce a higher energy yield by producing more hydrogen gas on demand. So
now, when Stan says this about the water going into an ionization state, what he's actually talking about is the dissolved gases and the ambient air gases in the water are being acted upon in the water. So when he says an ionization state, he's talking about the same thing. He's doing this ionization with the outside. Air and removing electrons, but he's also got the ability to do exactly the same thing to the air gases that are in the water. So this in turn improves the output of the electrolysis, and he improves it to the point where you can make huge amounts of gas which are actually not necessary. But without this gas processor, he wouldn't be able to get as much gas out of this system.
unit that you see right here, we call this a gas processor, and basically what
Now this is where you have to really pay attention. Now this really is the invention. It's the gas processor. Inside this device here, there's rows of LEDs, red LEDs that are 660 nanometers. Right, Stanley Myers gas gun assembly. Right, this is the deal. Right, thanks to Alex Petty for his website and the picture. Right, what we've got is the gas gun and the electron extraction. You've got this DC power supply, and you've got a variable alternate gate circuit. And this gate circuit runs these two optocouplers. And these optocouplers they switch on and off with this controller, and the controller has one on and one off, and similarly one off and one on, so they go back and forth. Now, if we energise the circuit, then what happens is the initial stage is that this optocoupler controls the switching to the transformer, and it is at a certain frequency and it's gated. The transformer ups the voltage and it goes to the positive side, and it goes through the diode into the inductor, creating a magnetic field, and it restricts the amps and ups the voltage, and then it goes to this inner positive. Okay, now this outer is the negative electrode, and the gases run between these two. And what people are doing is they are charging this up with the voltage circuit and getting to the point where they're ionising the gas that's inside here. But what also happens is that this controller switches and the optocouplers swap over. Then there's a second period, and in the second period these so-called ionised gases then run, the negative side runs here through a resistor to the positive side of the circuit, and that burns off electrons supposedly. Now, if you take, well, first of all, why is there 3 electrodes? Okay, now tell me why there's 3. If this is a positive and this is a positive, then why could there not just be a diode here from this electrode? So as the extraction, remember this, the whole circuit has been switched and this is off. So with a diode here, then the negative charge electrons could run through the resistor to the positive side, right? Now, Stan would never have added anything that he didn't need it. So let's say this is here because it's further away, so why didn't he just extend this tube another couple of inches longer, and in the second off period of charging then it would extract electrons from this tube? I don't think so. This tube here, the positive, is a coated capacitor, and this capacitor is being charged with the circuit, and the circuit is tuned to resonate the capacitance of this single coated tube capacitor, which takes capacitance with the air next to it. So it's stainless steel, and it's a resin or a dielectric coating, but an insulated coating, and the air that's outside of the tube gets attracted to it, and it has a capacitance. And the circuit's tuned from the capacitance of this air-coated capacitor, half-air capacitor, and this inductor. So the ringing is between these two, and this is just a negative electrode which runs to ground, and the air is in between. So the air is essentially in a unipolar. So the air is essentially in a unipolar zone, because this coated electrode has a capacitance effect, which means this coating becomes negative, and this is negative of very high voltage. So the air has been dragged through a unipolar zone, negative zone, and the air, like a fluorescent tube, it causes electron bombardment with the ingoing gases. Now, on the off cycle, then the reason there's a third electrode is because this one is coated. So this one can't do electron extraction. It's just, this is a single tube coated capacitor, 2/3 of a capacitor, and it's using the air, the capacitance it can build from the charge in the air, and that's been resonated between these two, the inductor and that capacitance. This is the negative, so the spare electrons aren't going to be attracted to this, they're being repelled. So in the second stage, when the capacitor is turned off, then this is a stainless steel electrode which runs to the positive side and burns off in this resistor the negative electrons. This is how this thing works. This is why there's 3 electrodes and not just 2 electrodes, one slightly longer than that, and a diode. It's simple. The capacitance of a coated electrode comprising of the air, the dielectric coating and the stainless steel is going to be really quite delicate compared to a dead short. So the capacitance of that tube resonating here is what causes electron extraction. So this is the gas gun that you can, what you would do if you were going to make the magnetized argon, is you would be running argon through here. It would be getting forced through this double negative zone. It would be charged with laser light. The spare electrons would be plucked off from here, and it would go on, and at this point, this is where you would have your atomized iron particles like Roscoe was doing in this chamber, where you spark atomized iron, but the gases at this point are so electron deficient and want to go back into a lower state, they will take up the iron atoms and you will get a magnetized gas. So the key to this is quite simply 3 tubes. Why? It's because this one is coated. Each one serves a purpose. Okay, cheers everyone. Okay, just to clarify from my previous video that what I didn't make quite clear is that you have the charge time and the off time, and on the off time, like the cell, the negative, the collapse of the inductor draws electrons essentially back into the inductor and into the positive side. So this tube here on the off time is doing electron extraction, like in the cell. Now that's the cause of the water breakdown and the gases, it gives off gases and right up to spark ignition. But what I wanted to just make clear is the electron extraction, the way Stan would have worked it, he realised what was going on. He's got a coated probe and he's got this outer. He's using this as a capacitor, and when the coil collapses it wants to recharge and drags electrons in through the diode into the coil, because the positive side is from the probe to the inductor, and this side of the diode is positive. So it runs through from earth back to charge the coil, and this is why you get an imbalance. So you're already having electron extraction in here. I didn't make this clear. This is what goes on in the cell, this electron extraction. But what the extra stainless steel electrode here, so you've got a probe, an electrode. Now, funnily enough, it seems odd because this is a negative, and as the coil collapses it wants to recharge. So this is causing extraction, this tube here. But also, this is a higher level, this is the gas gun, so it's a higher level of extraction. Okay, so this here goes to the positive, it runs through a resistor because the electrons he's trying to get rid of are negative. Now, it's hard to get this round your head to see the whole system, what I'm proposing working, because on the on time, there is a unipolar gap between the capacitor and the electrode, and on the off time the collapsing field is extracting electrons from here, and likewise simply because of the collapse and the size of the inductor electrons come, pressure, minus pressure has been applied to the capacitor plate, which is the water. In this case, the air, and so essentially this is the same as what I'm saying. This piece here is the same as what I'm saying in my previous videos, and this stainless steel pickup is a higher level of extraction. Now, that might sound hard for you to work out, but When Stan worked out what he was doing, he used the 2 for the cell and for this same system for the spark plug. Now, using the collapsing field to pull the electrons out and give it a deficit, and right up to spark ignition. There's also 2 stainless steel tubes, which is basically like a cell, but the positive tube has got a dielectric barrier on it, which is a quartz tube. So you've got an inner negative stainless steel tube and about a 1 mil gap or so, and then a quartz liner which is on the inside of the outer electrode or tube, which means that it's essentially what's called a dielectric barrier discharge. It's a plasma reactor. You put high voltage into this, and what happens is that you essentially electrons get pulled off of or fired off of the negative side, and they want to head across to arc out to the positive side, but there is a glass, basically there's a glass barrier in the way. So what happens in turn is that these dielectric barrier discharge plasma reactors, they use them in labs, and what happens is they charge up the ingoing air which is going in through this port here, and this port has actually got a restricted orifice, so the engine's pulling a vacuum on this. Well, not so much a vacuum, but a low pressure from the vacuum of the engine. And when this is charged up with a pulse frequency, of high voltage, then you, just like an ozone machine essentially, like Stan says, he ionises the air. So the electric field and the bombardment of electrons running across the gap excites the ingoing combustible gases, which is your air, and you excite them so much that you, first of all, you get a purple glow from the nitrogen and a bit like a neon light. But what actually happens to the constituents of air is they get charged up and excited enough to what's called, they go into what's called chemical resonance. And chemical resonance is where atoms get so excited that they actually release their electrons and they start to share electrons with other nuclei in the mix in here. So this chemical resonance is essentially moving the electrons away from the atom nucleus and causing them to be shared. So it's a quite intense plasma field that the intake air gases are going through under very low pressure. So it's almost like atmospheric discharge, a bit like the Northern Lights. It's just a plasma reactor, same as an ozone machine. But the key to this device is that he repeatedly charges it up very quickly, and he gets this plasma to excite the gases inside the gap, and this circuit is actually lined up with two resistors or one resistor, depending on how it's set up. And when you switch off the charge, then the cell or the tubes inside here with the active charged gases, which are in chemical resonance, are discharged when this charging time stops. It switches off, and this is like a bit of a battery. And because it's fully charged, and what happens is that it gets drawn off to a resistive load. So this gets charged up until chemical resonance, a very highly charged state, and then at the end of the charging state, then this unit and the gases within have a certain amount of capacitance, a bit like a battery, and then they can be discharged to a resistor like a light bulb essentially. And when you discharge these ionized gases, then because you're in chemical resonance, then you actually can force the oxygen and most probably other atoms in the air mixture to release electrons. And oxygen can go down to 4 electrons from 8, and these electrons get burnt off in the resistive load. Now, like I said, there's rows of LEDs inside here, and the LEDs are there to basically transfer energy to the nucleus of these atoms. Now, if you keep the nucleus charged with laser light or LED light, then it's just a coherent frequency. Then what happens is that they are a bit less bothered about losing their electrons or having electrons at an extended spin circumference. So essentially you are charging up the gases going through and instantaneously discharging them, and that's reducing the mass of each unit of gas that goes in to the combustion event. So this combustion event is affected by this gas processor. So when you get hydrogen and oxygen, it's equal to 2.5 times that of gasoline with energy. It has 2.5 times the energy of gasoline per unit. But the thing about what the twins realised is that the problem is when you create the gas, this is the cell here, the 11 tube cell with a small gas pipe, but when you create the gas, it's relatively energy intensive. You know, you end up with an amount of gas which is less than the amount of energy you put in. But what these twins worked out was that when you burn the gas, you actually only receive 1/millionth of the energy. And so you make a gas from the cell, and it's a dry hydrogen oxygen gas with no water. It's pure gas, and when it goes into combustion, the ignition occurs and a certain amount of energy is released, but the majority, 99.99% of the gas turns back into water. So water has got to be looked upon post-combustion as a byproduct. You know, it's the waste of the combustion moment. So this gas processor here is reducing the oxygen mass down to 4 electrons. Now, the oxygen is 8 times bigger than the hydrogen atom. So it's got 8 times the attraction force over the hydrogen atom, over the hydrogen electron than the hydrogen atom has. So when you add this combustible ionized, mass reduced to a resistive load oxygen, at the moment of combustion with the fuel, then what happens is that you get more than 2.5 times the energy output from the event. So they worked out how to go beyond the natural shutting down of the conversion from gas to water and extending that window by using this gas processor and the mass reduced oxygen. So the mass reduced oxygen goes into the combustion moment with the gases, and when the ignition happens, then the oxygen that really needs to find 4 electrons, and it's in a highly charged state, unstable state, will quite happily remove electrons from any hydrogen atoms that are during the combustion moment. And these hydrogen atoms are forced by nature essentially to do they're forced to give up their energy, their mass to energy, and even although one hydrogen atom is really a tiny amount of energy, if you've got millions of them and millions of these processed oxygen atoms, then they appear to take an effect on the combustion moment, which releases more energy per unit.
We're ionizing the ambient air gases that is now going into the process, and this allows us to trigger and use the hydrogen fracturing technology.
So he talks about the hydrogen fracturing technology, and that's what I was just previously explaining, is that you're taking a normal burn of hydrogen and oxygen, you're adding these processed gases, and what he coined the name of hydrogen fracturing is essentially these large oxygen atoms that are desperate for electrons will overcome the hydrogen atoms ability to hold on to its electron and force it to give up its mass to energy, increasing the output of the burn and less waste.
Tapping into a higher energy yield coming from the hydrogen.
You see, he says we're tapping into a higher energy yield coming from the hydrogen. That's the hydrogen fracturing process. That is the invention. Everything else is about efficiency. The cell, the electronics. He just brought Faraday electrolysis up to date and then expanded on that to make it extremely efficient. But without the processor, the car wouldn't run, essentially. The processor is key to releasing more energy from the hydrogen, and similarly later on he shows you the direct injector, and he explains that water can hold up to 17% ambient air, which is what the fish breathe. They don't breathe the oxygen in the water, they breathe the air that's diluted in the water. So water can hold up to 17% diluted gases. So what Myers was doing was he was producing gas-processed gas with deficient oxygen, for electron deficient oxygen. And then he diffused this gas through the water. And when he diffused the gas through the water, he fed the water. And the mixed gases to the injector, which removes the need for producing gas, because the injector, everything happens at the tip of the injector. I'll go on to that.
miniaturized down to a very small, lightweight system.
Without pre-mixing and diffusing the gases in this from this processor.
Fuel now coming from the water through the electrical polarization process going into resonance. Resonance meaning that we're actually tuning into the dielectric properties of water, and it allows us to reduce amps down, flow down to a minimum, and allow voltage to take over that disassociates the water molecule on demand. And those fuel gases are now coming through this electronic injector system, as you see here. Control of the fluid mediums are for fluid mediums, and as a result now we can tune in and allow this engine to run off of natural water.
The GMS unit up at the dashboard is controllable and will also meter mix the gases across the dynamic range of the engine's capabilities.
This system's approach, this particular unit here is referred to as the VIC, or the voltage intensified circuit technology.
Now these cards here, there's one here for each cell, and there's ones for the processor. And what these basically are is pulse signal, DC signal pulse generators. And they create a signal, and plugged onto the bottom of them is some quite reasonably large transformers, one for each card. And the transformers take the signal and multiply the voltage, I think it's times 5 or 6, to go to the cell and the gas processor. So this is the drivers essentially to run the cell and the processor, and the configuration is very similar. There is some basic differences, but in general he's acting on the gases in the water column, and he's also acting on the gases that are being drawn, the ambient air gases that are going into the combustion moment.
This is demonstrated in our systems engineering approach on the technology that we can apply it to other applications, not only in the transportation area, but also in industrial applications. So it was paramount that we would demonstrate and have the technology solved for design engineering, retrofitting to existing energy-consuming devices, whether it's being run in an internal combustion engine or a diesel engine, or hook it to an industrial process. So all of these design interfacing technology is now...
So what he's really saying here is that this unit with all the cards and the GMS unit is not just for the car. It's a design application which covers the many uses of this new technology. So if you were to, if he'd got to selling kits, the kit you would be buying for $1,500. Which hooks up to the ignition timing, or takes a pulse from the ignition timing, and essentially just the gas cell.
Being solved, we are in the latter stages of what we call the pre-engineering.
What's going on here? This is the GMS unit, the gas management system, and basically this is a pre-production unit that they had to put together that would cover not just the running of the car, but the multiple uses. this type of technology. So it goes beyond the car into home heating systems and jet engines and salination and various other new ways of clean and energy efficiently processing your hydrogen and oxygen to become an energy source. Now, there's no such thing as free energy, so you need to have a form of energy to use, just like people would use a battery until it goes flat, or you burn coal until it's completely consumed. Then the same applies to water.
Engineering design that went into this, even though that this is our systems engineering approach. The hydrogen computer system you see here will be miniaturized down to several IC chips, which will to run.
So what you've really got here, a closer look, is once it clears up, I think about here, more. Right, so what this GMS unit actually does, it's divided into 11 cards, and these 11 cards basically control, it's called the gas management system, and it controls the gas mixtures. There's essentially your hydrogen and oxygen from the cell, and then there's your processed intake air, which is all processed, no external air gets in, and your exhaust gas recycle, and the exhaust gas recycle. Basically reduces the burn rate of the hydrogen and oxygen, and you can vary it from these controls, and you can basically vary the burn rate to equal petrol or gas or diesel engines. The GMS input, the input for this unit is ancillary that's added to the distributor, which basically just sends a signal on every rotation of the distributor to this unit. This unit also does the ignition timing, which is the injection timing. Yeah, this essentially is very much like a modern car ECU, except the ancillaries attached to it are different. And as Stan says, this is really pre-production, so what would happen is this would just end up a small black box. With predetermined values depending on the vehicle, because it essentially mixes the gases, and it mixes the gases in a controlled fashion, just like a modern car fuel injection system or airflow system. It basically controls 3 gas valves, and one of those gas valves is the fuel. The other one is the processed gas from the gas processor or gas gun, and then the other valve is the EGR, the exhaust gas recycle. So you've got your fuel, you've got your enhancer, and you've got your exhaust gas recycle to slow the burn down.
Our systems engineering approach. The hydrogen computer system you see here will be miniaturized down to several IC chips, which will allow us to give the economics to apply to a conventional car.
The crocodiles maneuver around them with surprising ease. They are intelligent hunters, plotting their attack with precision. A strike can happen at any time. For the baboons, it's more like a spectator sport. They might as well settle down. A single croc can take some time to overpower its victim. But crocodiles are cooperative feeders. They work together.
Merch updates are ready. If you want to look good in the H2 hot rodding scene, and if you would like to pick up some hydrogen hot rodding merch, now is your chance. Please head over to our hydrogen hot rod shop. The link is in the description. Thanks. Alternatively, you can send me an email or join me on WhatsApp chat. The details are in the description. Let me know which things you like and what sizes you want. The global network of home builders is growing very fast, whether it's a roadster, supercar, or a yacht build, or maybe even an industrial power gas energy project. I'm here to assist and guide you. Please head over to the Consult with Dan link in the description and book a discussion for 10 to 30 minutes, and I will save you decades of study. Talk to you soon.